All right. So double angle formulas, right? So how do we get double angle formulas? So sure, we can memorize double angle formulas, but it's easy. If we can show how to get double angle formulas from something we already know, then why memorize it? So if I want sine of 2x, how do I get sine of 2x? Well, I know sine of a plus b. Sine of a plus b is sine a cosine b plus cosine a sine b. So the way I remember sine of a plus b versus cosine of a plus b is sine of a plus b, the expansion of that alternates between sine and cosine. So sine a cosine b plus cosine a sine b. For cosine it's slightly different. So if I take sine a plus b, what if I take a is equal to x and b is equal to x?
So I'm making everything equal to x, all of the variables
All the
equal to
variables
x.
equal to x.
Okay.
So now the left side becomes sine of 2x,
X plus x.
x plus x. The right side becomes sine x cosine x plus cosine x sine x, which are the same terms. So that becomes 2 times sine x cosine x.
And actually, you're done now.
Yeah, so that's a double angle formula for sine. We can probably do the same thing for cosine as well.
Right, so I'm going to take that same, well, not the exact same, but
Sure.
When we learned the sine of a plus b in high school, we also learned the cos of a plus b.
Uh-huh.
And this one is, cos, sine, sine.
Yeah.
To think about whether or not it's a plus or a minus in here, it can't be the plus, because I'm going to do the same trick as you did before.
Mhm.
I'm going to make a and b both equal to x. I'm going to make everything equal to x.
Uh-huh.
And then that would be cos squared,
Uh-huh.
and this would be sine squared.
squared.
And it can't be cos squared plus sine squared, because that's always equal to 1.
1, yes.
So x plus x, 2x.
Uh-huh.
Now here, cos times cos, like we said, I'm going to make that cos squared.
Uh-huh.
And sine times sine, I'm going to make that sine squared. And there's a double angle formula for sine 2x you made, a double angle formula for cos 2x.
Yeah.
Now, we can do a bit more, right? When you were asked to memorize these, when you were asked to memorize these double angle formulas, cosine had 3 of them.
Yes.
And if I go back and remember the sine squared plus cos squared equals 1,
Yeah.
I can solve that for cos squared equals
Sure.
1 minus sine squared,
Yeah.
or I can solve that for sine squared equals 1 minus cos squared.
And you can plug in those in there.
Right, so so plug in, you mean,
So I have cos square equals 1 minus sine square. So instead of cos square, I can just plug in 1 minus sine square there.
and now it's 1 minus sine squared minus sine squared,
Yeah.
which is 1 minus 2 sine
sine
squared.
yeah.
Exactly. This next one, though, I think I have to be careful about,
Sure,
right?
Sure, yeah.
So I'm going to take this same formula, and because of that minus sign, I'm going to throw brackets around.
Yeah, absolutely.
And in for sine squared, I'm going to write that 1 minus cos squared.
Uh-huh.
And now cos squared minus 1
Plus,
minus a minus.
Yeah, so that
is a
becomes
plus.
plus. Yeah.
So that becomes a 2
cos
here.
squared.
And that's a minus 1.
Yeah. So just knowing sine a plus b and cosine a plus b, we can get the double angle formula for sine and cosine.
So we've got 1 for sine and 3 for cos.
Cosine. Yeah. And I want to mention that we are showing how to get from sine a plus b to the double angle formula, and especially for cos a plus b to 3 double angle formulas. Now, the more number of problems you do involving these, it becomes easier to kind of knowing, I don't want to say memorizing this, but it kind of becomes second nature to just kind of get these formulas as the more number of problems you do with this. Because if you're in it, it's great to kind of get this starting from cosine a plus b. How do we get this? But it takes some time to kind of get to the double angle formula from cosine of a plus b. But as we do more and more problems, it becomes a little bit of second nature.
Yeah, I guess you kind of memorize them by accident.
Accent, exactly. Yeah.
And if you're doing this on a test or a midterm or something, and you're not sure that you've memorized them or written it down correctly,
Yeah.
one of the things I would suggest is just test, I gotta make that an X there, not theta, X.
Oh, yeah.
Test with a value,
Yeah, that's
right? Like,
absolutely right.
if I make X equal to, let's say, pi over 2,
Yeah.
90 degrees, that would be the sine of 180 degrees,
Uh-huh.
which should be,
-1.
180 degrees should be, the y coordinate should be 0, right?
Oh, you're absolutely right. Yeah.
So
yeah.
if I make sine equal to pi over 2, sine of 90 is 1, but cosine 90 is 0, so I get 0 on both sides.
Sure.
Anyway, what I mean is use a test angle that you know,
Yeah.
whose trig values you know,
Yeah.
and then you can check if you've written it down
Yeah.
correctly or not.
Yeah. And I also tell some of my students too, like, as soon as you get the test, just write these formulas out on the front sheet before you even start doing the problems, because this is fresh in your mind. You can even derive this before you start doing the problems, because once you start doing the problems, you get a little nervous and things like that. But before you start, you can just write it on top.
Yeah, like a brain dump at the top of the
Exactly.
page. Yeah.
Exactly. Yeah.
Okay, but the way that we've shown now about deriving them,
Yeah.
if you ever need them, now you can make them.
Exactly.